Welcome to The Explainer. Today, we're going to trace the path of real-time communication from the polite but kind of slow digital hello to a future where conversations can start instantly. And believe me, this journey impacts everything from your video games to the Internet of Things. So, here's how we're going to break it down. First, we'll get into the fundamental tug-of-war that happens in all network design. Then we'll look at the tax we all pay for reliability, see how a protocol called QUIC tried to lower that cost, and finally, we'll dive deep into a groundbreaking new framework called DeMoD that wants to get rid of it altogether. Okay, so to really get where we're headed, we've got to start with a core problem at the heart of all network design, especially for something as demanding as a fast-paced game.
At its core, network communication is this constant battle. On one side, you have responsiveness. You want your actions to feel immediate, snappy. But on the other side, you have consistency, the need to make absolutely sure that everyone in a shared space sees the exact same thing the exact same way.
And, this is not some new problem. Developers have been fighting this battle for decades. The architects behind the legendary game Doom 3 pointed this out way back in 2006. To make something feel real and immersive, you can't pick one over the other. You absolutely need both.
So, the big bad guy in this whole story of responsiveness, it's latency. And the way we measure it is with a metric called round-trip time, or RTT for short.
Yeah, just picture it like this. You send a letter, and you're waiting for the reply. That whole time, from sending it to getting the response back, that's your RTT. In the digital world, this is that frustrating little delay between you clicking a link and the page actually loading. All right, so to guarantee that other crucial element, consistency, networks have this very formal introduction process. But all this politeness comes at a cost, a kind of tax on speed that you have to pay right at the very beginning. For decades, the internet's go-to answer for this has been a protocol that forces a polite digital handshake. It's all about making sure both sides are ready to go before any real information gets exchanged. And that protocol is the absolute workhorse of the internet, the Transmission Control Protocol, or TCP. This is the unsung hero that makes sure your emails, your files, and your web pages all arrive in the right order with no errors. It is, by its very design, incredibly reliable. Now, TCP gets this incredible reliability by using a mandatory three-step process. First, the client says SYN, which is like, hey, can we sync up? The server replies SYN ACK, meaning, I got your sync, here's mine. And finally, the client sends back a final ACK, or got it, we're connected. Only after all that can data actually start to flow. And that right there, that's the tax. Before a single byte of useful data is ever sent, you've already paid the price of one full round-trip time. In a world that's all about instant responses, that initial delay is a massive bottleneck. Now, developers, of course, knew this handshake tax was a major drag. So the race was on to find a faster, more efficient way to get things connected securely and reliably. And that brings us to QUIC, a protocol developed by Google to just streamline the whole mess. Instead of having separate handshakes for the connection and for security, QUIC just smashes them together. It cuts the required round trips from 2 or 3 all the way down to just 1, or maybe even 0 for returning visitors. But here's the other really clever part about QUIC. You know how with old-school TCP, if one tiny piece of data gets lost, everything behind it has to just wait? It's called head-of-line blocking, and it's super annoying. Well, QUIC uses multiple independent streams, so one little error won't bring the whole show to a grinding halt. So you see this pattern, right? This constant push to streamline communication and kill delays. And that evolution brings us to our main focus today, the DeMoD Communications Framework, or DCF. This really is the next logical leap forward. DeMoD looks at the handshake, even the faster one in QUIC, and asks, what if we just got rid of it entirely? For real-time applications that need to start talking now, DeMoD uses a truly handshakeless design. It just skips the formal introduction and gets straight to the conversation. And the payoff for this approach? It's huge. I mean, you get the obvious win, insanely low latency,
But its power goes way beyond just speed. It's built from the ground up to be modular and flexible, working across different protocols, and even creating these robust peer-to-peer networks that can literally heal themselves if a connection fails.
And this is what makes the framework a real game changer. It's incredible interoperability. This isn't some niche tool for one specific job. It's designed to be a universal translator for high-speed communication, running on everything from tiny embedded devices to massive cloud servers. And yeah, even the phone in your pocket.
Okay, so let's zoom out for a second. Why should you care about this if you're not a gamer? Because the implications of truly instant, handshakeless communication, well, they're massive. It's simple, really. Once you get rid of that initial delay, that handshake tax, you unlock the potential for a whole new class of technologies that are becoming totally central to our digital lives.
The big takeaway here is that frameworks like DeMoD are the engines for the next wave of connected systems. Think about the Internet of Things, with billions of tiny devices needing to exchange small messages instantly. Or edge computing, where processing needs to happen as close to you as possible to reduce lag. All of these depend on minimizing latency from the very first packet.
This really brings the whole arc of our story into focus. We've seen network communication evolve, from the slow, formal, but necessary handshake of TCP, to the streamlined introduction of QUIC, and finally to the direct, immediate conversation that frameworks like DeMoD are making possible.
And all this progress leaves us with a fascinating question to chew on. In a world that depends on instant connection, for everything from our games to our smart homes, are the days of the polite but slow digital hello numbered? It seems the future of communication isn't about the handshake, but about getting straight to the point.